Right. So we were discussing about creating a simple student class which has a name, one variable, and during the construction of the student object we have to assign the name. So we'll assume that user, when it create a student, it will provide you a name. So that was the understanding. So this is how we are going to start def. We'll have 2 underscore init, 2 underscore. Sometimes we call this is a constructor. So we have a self method. Now you know the self keyword which applies the same, and we are going to get the student name, right? And then I'm going to make assignment. I'm going to say self.name. Name is our variable, and then we'll assign student name. Sorry. Run and see whether this is working, because this is the first step. Done, finish? Yes. Now what we did, we create a class for student. We have one attribute name, right? Whenever user create the student object, right, and that name is assigned to the variable name. That's what happens here. Now let's create some students. So let me say I'm going to create my first student S1 equals, usually we will put up the class name student, and now when we are creating a student, now you see here it will expect what? Student name, right? So we'll provide some name, give any name you want. I will say put Sama, right? Now I'm going to print S1.name, and hopefully it should give me the name Sama. So the dot operator you might have already seen earlier, like we put a dot and we put something and we get some values. Finished? Yes. Need help? Yes. Whenever you get error, just let me know. Case sensitive. Can I have your attention when you are creating the class name? Here I use capital S. So student with capital S. So make sure you use the same format, because in Python we discuss its case sensitive. So if you type student with capital S and student with simple S, they are two different things in Python. Any simple error, just let me know, which I can explain to the others as well. Are we clear up to this? Right now we have not defined any methods, right? No methods, just the variable. Now when we want to define methods, let me take a method. So this method, I'm going to define getName method, where it will just return, right, in this case self.name. So basically what happens, this is not recommended usually. That means directly you access variables within the objects. Instead we can use methods. So how do you get the method? Same thing, I can say getName should return. So remember, I'm going to run this. Yes, run this. Same outcome, but slightly different ways of usage, which I will explain. So that's all I want to discuss under the object orientation. So how a class look like, and how we create objects, and how we access methods in the classes. So this fashion you might see, like many of our previous ones, we have used this, right? For example, we said list dot sort, right? So what we did is we put the list name dot, we said sort, which access the class list. Within that it execute the method, right? So this is the way the classes are written, and most of the time in Python all the data types are classes. So in the note you will get a complete example of implementation of credit card, which I am not going to do it now because some of you are very new to programming. If I do this, I don't think I can teach you anything else today, right? But those who are interested in learning, I have a complete example. Remember our credit class? How we initialize the credit card with the customer name, bank name, account name and credit limit. Balance, of course, we know it's 0 in the beginning. So when we create the credit card, we use this fashion. This is object name. We are providing the class name credit card and we are sending this information, the name of the customer, the bank name, account details and also the credit limit, right? Which will create the object. And then after that, we have implement all the methods and then we can actually check, how, for example, here, it's some example of using the credit card. So after creating the credit card class, this is how we can access the value stored under the credit card. And this is this will show you what will happen when you're making a purchase. The balance will increase, and then you are trying to purchase item worth 30,000, but credit limit we put 50,000. So already you have made a purchase of 25,000, which will not allow this. Then you are making a payment to the credit card. So try this code. Those who are interested and those who had some experience want to know about how this works. For the majority of you, the simple idea would be a class. I hope you get an idea how the class is structured and how we put up a variable, we get the values and store, and finally we show a one method. That means getting a name. So that understanding is enough for me to continue, right? That's all what I want to talk to about you in object orientation. The idea is, like many of the things that we interact in the Python are written as classes. So always we create an object and then we call the methods. So that's how we used to interact in most of the time, right? I think now we came to the data analysis part where more interesting things come on. Right now, up to this point, we discussed the basics. Basics means the basics that you need to develop programs. So those who have not done programming, so far what we have discussed is just the basic structured programming. We discussed things like variables, things like control structures, the data structures, the object orientation. That's the basic. Now from this point onwards, these libraries we use are directly relevant to your data analytics. So the numerical Python is the library extensively used to create vectors and matrices. Now when you say vectors and matrices, the idea is when you want to represent your data in different way, or you can create your own data. Sometimes we have to create our own data to check things. So in this part I am going to talk about how numerical Python can be used to solve common problems in data analytics, right? So let's start. Now this is a library, and this library is used to access or create what we call the vectors and matrices. If you are not familiar with the vectors and matrices, it's simply one-dimensional. It's just a row is a vector. If it is two-dimensional, when you have rows and columns, we call it a matrix. Simply, just remember like that. If you are not very familiar with the two terms, vectors and matrices, right? Okay, now first of all, we have discussed lists, right? What are lists? What are lists? We can have multiple items under a single name, which are ordered, yes, which can be manipulated. Yes. And a list can have mixed data types as well. If you remember my example, apple and 5, you can have mixed data type. So that's lists. But then this NumPy arrays, we use the term NumPy arrays, which is a special data structure. They implemented efficiently so that they are efficient handling large data sets. So therefore, many of the time when we deal with the data, we represent them as NumPy arrays, right? So this code will shows you the difference in brief, how we use list and how we use NumPy arrays. So in a list, let me take right. Now under this, you remember this code early. Here we are creating a list with 3 numbers 1, 2, 3, right? And when you say print type test1, it will tell us the class of this is a list class, right? It's a list, right? Second one, same thing I'm going to represent as a NumPy array, which is what our topic for the rest of the class today. So in NumPy, we are going to first call the library. So what this means is we are going to import NumPy as NP, which is a library which contains a set of functions which we can use to manipulate vectors and matrices. Now this time I'm going to say test2, which is a NumPy array. So there's a method. When you type now like this, now I hope you are now familiar with the use of this. So under that I will create a list like this. But this time when you print, right, so this one will tell you that now this time when you define our test2, it's an example or it's a class of NumPy n-dimensional array. So when you work, remember, for small data or small work, you can define like this. There's no change of these two techniques. But when your data gets large, this method, this technique, or representing them as NumPy arrays are more efficient. So remember, that is one of the reasons why we are creating NumPy, or we are using NumPy arrays. So this part we have done early, and from this point onward, this is how we are going to use. We are going to import a library called NumPy as NP. We shorten the NP, and when we are creating a list, we use especially this method, right? The difference is this method you can have only one data type. If you are using NumPy arrays, remember you can have one data type. You can have numbers, you can have strings, but mixed data, they are not allowed here, right? So make a note of that. If you need more information, you can use help np.array, which will give you information about how to create it, which I am going to explain now. Now, when we use this library, there are methods we can use to get more information about the arrays. So the next one I am going to explain how we can create one-dimensional arrays, or in case vectors. So I am going to talk about vectors, in other words one-dimensional arrays, either row or a column. Right. The technique we have discussed is, let's say I'm going to create a vector called A, and I'm going to say np array. So this is the method I'm going to use. I'm going to have a list of numbers like this. Let me print. You don't see any difference when you print it. It's very similar to lists. Okay, but then you get some extra methods. For example, you can get the shape of this, print a.shape. The shape is number of dimensions. That means length. So it says in this particular case we have 4 elements in here. Actually, when you have rows and columns, this will put both rows and columns. Right now we don't have any rows here. Then another method, a.size, will give you a number of elements. It says 4. These are very useful. For example, when we work with the data, we can get the data shape, we can get the size, a small question, like let's say I want to access the first element. What is the code? I want to access the first element. What is the code? Same as in previous cases. In list, how do you get the first element? We have to say A. It should be 0, right? Which will print the first item. Anyone having issues? No issues? Okay. So those who have done mathematics, maybe you know there's two types of vectors we can have. We can have row vectors and column vectors. This one actually what we call the row vector. So let me show you a column vector as well. Same thing as a column vector. So let me make it as a B. Same np.array method. Now this is a column, which means every row we have one element. So I'm going to have 1, 2, let's say 4, 5. So you can see the representation now has changed. It's a column vector. Now try the shape and size and observe the outcome. Yes, when you get shape, what is the shape here? What is the shape? Now in this one, earlier we didn't say this properly. Shape, number of rows and columns. Now this time it will give you properly. It says 4, 1, which indicates that you have 4 rows and 1 column. And then when you say b dot size, it tells us, okay, there are 4 elements. Do you remember the range function in for loop? Range function in for loop? Range function with the for loop? You remember that? Yes? For example, if you want to print numbers from 1 to 10, how do you put the range function? Yes? Let's say we want to print numbers from 1 to 10. Those who are not here, let me explain. So we can say 4, I in range. This is the function we need to use. The range also have the same start, stop and step, right? So what is the starting value? Starting value is 1, comma, stop value, you want to go up to 10, which means, and if you say print time, it should print. So those who are not done, maybe you can quickly do it and see. Because this is the same thing I am going to discuss. So if you say for I in range 1, 11, and if I say print I, it will print numbers from 1 to 10, right? The range function. If I want to print odd numbers, if I want to print not all the numbers, only the odd numbers, how do you keep? Yes? Odd numbers, we have to say 1, comma, then 11, comma, step should be 2, right? If you just put comma 2 here, you will notice what? Agree. Yes? If I need even numbers, let's say 1. No, it's you have to start with 2 then, or 0, right? So let me put 2, the starting value, which will give you even numbers between 1 to 10. Right. Now, why I actually recall range function is, now vectors, when you want to generate vectors automatically, sometimes we need to create our own data, right? So we need to learn some function which generates the data for us. So similar to this, if you want to create a list of values, we can use a range function. So similar to this, there's a function called a range. So a range will generate vectors, right? So for example, if I want to generate a vector, let me say C from 1 to 10, what should I type? Now this is not range, this is a range. If I want to have a vector with numbers from 1 to 10, what should be the start value? 1, end value 11, and let's print it. When do you need this? When do you need a vector like this? Sometimes when you want to draw a graph, if you automatically create a set of numbers, we can use this technique. Small exercise. Create a vector D which includes odd numbers from 1 to 100. Yes, how do you create a vector D? I need only the odd numbers from 1 to 100. So how do you create? Yes, how do you type? D equals np dot a range, starting value 1, n value, yeah, you can say 101, let's say. Step should be 2, right? That's all. So if you say print D, this should create a vector like this. I hope now you are comfortable with this function. I would like to introduce another function. The second function is called linspace. So this will generate linearly spaced vector. What it means, given 2 points, let's say between 1 and 2, you can tell, right, you need this many number of points. When this is useful, again when you want to draw graph, let's say -5 to +5, likewise we can give start and the end, that will generate linearly spaced vectors. That means the space between will be the same. Let me give an example. So let me say y equals np dot linspace 1, 100. Yes. Now print y and observe the outcome. Yes, you got an outcome. How many points are there? How many points are there? Yes, how many? You don't have a count, you know the method, right? What is the method? Yes, we can say. How many elements are there? You can say print y dot size or shape. You can say. So you can see the value is between 1 and 100. Observe that it's between 1 and 100. How many points? 50 points. Just check the help it will tell you that. If you look at help, np dot linspace, if you check this, it will tell you like this. Yes. Now this is from the help. It says linspace start and stop. That's all we give, right? Returns equal space numbers over a specified interval. We have given 1 and 100. We have given how many points? How many points? 50 points, which specified here, right? So that means you can change if you want. Right? You can read the remaining. It will tell you that if you just give your two numbers only, it will create 50 points between the two numbers. Now let's say I need 100 numbers, right? I need 100 numbers. So here the number is optional. Number of samples to generate, default is 50, right? So let's change that. So what I'm going to do is I'm going to put 100 as a third point, and if you check now, what you will see? What do you see now? Now this time, between 1 and 100, we have created how many points? 100 points. What is the data type? By the way, those who are not here, we discuss integer data type, then float, and then string. So what is this data type? It's float, right? Remember there's a decimal point. If there's a decimal point, this float, right? If I need integer value, then you can say D type, I can say int. Which will give you integer. You better not to change the same place, maybe you can copy the code in separate codes. So the first point, when you just say the two numbers, what happened? We created the 50 elements between 1 and 100. When I put 100, we create 100 elements between 1 and 100. Now we say data type, I need them as integer values. So here we are getting values as integer values. Now, are you comfortable with vectors? We discuss row vectors, column vectors, two vector generation functions. Yes? Right, next one. Finished? You need more time? Those who need more time? You are comfortable? Okay. Let's move to the matrices. Now matrices, on the other hand, we say two-dimensional arrays. Usually our data, we have both rows and columns. Similarly in matrices as well. So let me create a matrix A using NumPy array. Now remember, in matrices, every row we have to have a list. So I'm going to have a list like this: 1, 2, 3, 4, 5, 6, 7, 8 and 9. All these we have done earlier as well. Same. So you got the idea. This is the first row, second row, third row. So we have 3 by 3 matrix. That means we have 3 rows and 3 columns, which will get the shape. What is the size? Number of elements. How many elements are there? 3 by 3 means there are 9 elements, right? Okay. Now, similar to the previous two functions, we have several functions are there for generating matrices as well. So let me introduce one, but the note will give you more information. Right. The first one, finish up to this point? Yes. So we'll start with method ones, right? So idea is like this. So actually you can generate vectors as well. So for example, if you say print np.ones, and if you provide a number like this, this will give you a vector which fills with ones. Right? The size is 5. So similar to that, if you say np.ones, if you put 3, 1, those are 2 vectors. So how do you generate a matrix? How do you generate a matrix? So same way, let's say we will say print np.ones, let's say 2 rows and 3 columns. So we get 2 by 3 matrix like this. Right. Try the same. Instead of 1, put zeros. The first one is ones. Second one, put zeros. Instead of ones, put zeros and observe. You can create vectors and matrices filled with zeros. Yes, have you observed zeros? Yes, okay. Next, random numbers. Use of random numbers. There are two techniques we are going to discuss. You can write like this: np.random.rand 5 will generate a matrix with random numbers, 5 random numbers. Run multiple times, you observe the numbers are changing. You get different sets of values, right? Every time when you run. Right. If you put the seed number, it won't change. Now earlier when we run this, every time when you run we get new sets of random numbers, yes? Now put this line before and see the outcome.
So what we want in now these are foreign numbers, but if you want integers then we have to
We have a different method. I will explain. Are we getting the same result? Yes? So be careful about random numbers. Because when you are presenting a work to the others, if you are using random numbers, what will happen? Every time you run, you get different results. Yes? But if you want to get the same result, then we have to fix a seed value. Seed value is actually, we can make it to fix a set of random numbers. So that could be 1, 2, 42, I don't know. You will see. When I explain machine learning, will explain the import of seed value, but for the time being, remember, when you're using randomness, always gives you a random value. Right? Now, for example, if I'm teaching for the students, if I give you, right, okay, this is the answer. For every one of us, we are getting different answers, right? Yes? If you want to fix it, we can have a fix, we call seed value, which we can fix. Right? So, this is how we generate a vector. So, if you want, for example, a matrix, we can say you can specify number of rows and columns, let's say 2 by 3, which will give you a random matrix. So earlier we put only one value. Again here what will happen? We are getting different values. If you want to fix it, specify seed value. Similar to this, there's another method called randin. There's a similar method. So instead, are you familiar with the normal distribution? The bell-shaped curve? Okay. So if the numbers you want to get it from a normal distribution, if you don't know what it is, just forget about it. But for the time being, let me say, if you want to get it, the values from normal distribution, we can say random randn. Random numbers normally distributed one, it says randn, and we can, let's say 2, 3, like in early, which will give you again a set of random numbers, but this time the random numbers are drawn from a normal distribution, which come from the statistical normal distribution curve. We use that to draw the random numbers. This is another technique. Okay, third one, if you need random integers, there was a question like how do you generate? Here is how we are going to generate, slightly different. Let's say random integer value. If you just want one value, it's like this. We can say print np.random.randint. That is the method. And if you say 1, 100, this method draws you only one value. Just run. It will give you a number between 1 and 100. So every time when you run it, yes, you get a number between 1 and 100. Yes. If you need a vector, it's like this. Second one, we are generating 10 random numbers. Third one, if you want to create a matrix with some random numbers. Right. Are you now comfortable with creating vectors, matrices in various different ways we discussed? There are many more, but at least these are some basics. Now, given a matrix, let's discuss how to access elements. Right? So, retrieving elements from a matrix. So let me define matrix X, np.array method. I'm going to have 4 by 4 matrix. Actually, you don't have to type like this, but for the time being, we'll type because I didn't explain how to generate something like this. So it's a 4 by 4 matrix, isn't it? So let's print X. There are easy way to do this, which I will explain later on. Done? Right. How can I access? Okay, this is the question. Let's say I want to access the element in third row, fourth column. third row and fourth column. Which elements in the third row? So this is the third row, 9, 10, 11, 12. Fourth column? Yes? What is the value? Third row, fourth column. What is the value? $12, right? We want to access 12. How do you access it? Yes? Let me use print x. Okay, there are two ways we can do, but let me give you the best way. First, specify the row value. What is the row? Index. Third row means index, start with 0. So 0, 1, 2, right? So we can say 2 comma. Fourth column, and the index is 3, right? 0, 1, 2, 3. So if you put 2 comma 3, can access the value 12. So I hope now any element you can access. Yes? Are you? Okay, another quick question. Try access third row and access fourth column. Can you give me the answers to these two? Right, what is the answer for the getting the third row? Yes, we can say print x. Yes, third row is anyway 2. And how do you say all? We discussed earlier. Colon, right? Remember? I don't know whether you remember, I told you like 1 to 10. But if it is start from the end, everything I told you, it's the colon. The same idea we can use here as well. So it will give you the third row. Similar to that, if you want to access the fourth column, can you give me the command? Print x colon comma 3 should give us yes, fourth column. Right, done. Before the break, but now we are going to have the class test, right? Which things we have covered in the today's session, right? Hopefully. Shall we start then? Maybe you can use your employee numbers so that your names are not visible, right? And we need this to give away the certificate, isn't it? We are counting this, right? Use your employee number, but don't type something else, huh? Because I'm going to get your names from the from MS. So don't type any other thing, just your employee number so that I can track back. How many of us are here today? We have 11. Any technical difficulties? No difficulties, right? Anyone is having trouble? Okay, we have 4. 7 more. So what matters to me is overall count, right? The class average. So remember, everybody should work hard. So this will be the assessment for me then, right? Okay, we have 5 more to go. So this is individual assessment. Try to answer alone. It's perfectly all right. Two more. Okay. One more. Okay. Shall we start? Ready? not good at all. Anyways, so this is a list, right? And when you say end node, we are referring the first item. Oh no, not yes. End node means the first item. So the answer should be the blue one where you update the first item as table, right? Okay. So let's see who are the winners for this. Who's 975? Okay. Okay, let's see what will happen to the next one. I hope everybody will get the correct answer for this one. Okay, that's good. Everybody save my day, otherwise I'll get really disappointed about that. Okay. 970 and 389. Third one. Okay. Actually, I didn't discuss one of the answers. The yellow one is also works because when you say x2, it will give you the third row. But I think the majority you got the answer for the blue one. Okay, that's one good. A1 means the second element, which is 2. Okay, that's also good, which means at least you are comfortable with what we have covered today, right? Okay. 590. Okay, that's also good. 267. Yeah, it's a let's data structure, right? 219. So there's a lot of competition. The third place, it seems. Okay, that also good. We discussed this. Okay, no change of orders. Oh, what happened? I thought that was an easy one, right? So it starts with 1, goes up to 3, not including 3, that means 1 and 2, only 2 letters, right? Okay, it's actually a column vector. We have 3 by 1. 63? Okay, I guess this is an easy one. Okay, that's good. Okay. $389. Yes, 389. Ah. Okay, that's also good. Two more questions. Okay, that is also good actually. So what happens, we are creating a test class and we are expecting a message from the user. That message is assigned to a variable called message, and this function will display that message. So the message is dialog, the dialog will be displayed. I think the last one. Okay, that is also good. Right. Who is the winner? Third place, maybe you can raise your hands. 970. Okay, third place, congratulations. 389. First place, 975. Fourth and fifth places, 517 and 63. Okay, so let's congratulate everyone. Huh? So it's a break time. Diriti, what happened now? We'll go to lunch and come back, right? So we'll break for lunch and then we'll meet again 1 hour. So I can see the class average. Can I see? I don't know how to find that. Anyway, we'll stop the recording.